Hey there, welcome back to this video on lesson 1A-1. This is the second half of the lesson where we are going to talk about key features of polynomials, specifically concavity, how a function opens and how it is affecting the rate of change. So, just a reminder about our learning intention and our success criteria. And we are specifically going to talk about concavity. So, a curve is called concave up, concave down, or both. If the function is both, then the graph will change from one to the other at a point called a point of inflection. So this is where we change from a point of inflection. And we have some examples here. Here is concave up, and remember that concave up is like a cup, concave up like a cup. Okay, or a smiley face, and then concave down is like a frown. So here is concave down. And you can see an example here where we have a concave down curve. Our graph is concave down. It's opening downward, and then it changes into concave up, like that. And where it changes, that point is called a point of inflection or an inflection point. Okay, pretty straightforward. So here's a practice problem, and we have given you the points of inflection. You can see here at x equals 4 and x equals 8, and you just want to go ahead and identify each section as concave up or concave down. Okay, go ahead, pause me for a second if you need to, and label these sections. Okay, hopefully on the interval 0 to 4, you said that this graph, this is concave down, and where it changes, it is now concave up from 4 to 8, and then our graph goes back to opening down. That is concave down. Good. Okay, so just some basic practice there of identifying those. Now, I want to go ahead and I want to talk about rate of change and concavity and how they're specifically linked together. Knowing one can tell you the other. Recall that we have learned that for a line, its rate of change is the same thing as its slope. And for other functions, we've learned how to calculate an average rate of change over a specific interval. Rate of change is the measure that describes how two quantities are changing together. An example would be if James earns $17 for every hour he works, it's a rate, right? Dollars per hour, or like when you're driving a car, miles per hour. The rate of change, $17 per hour, or James earns $17 per hour. Yeah, that's what I just said. For functions without context, it's helpful to think of rate of change as slope. Okay, which is a measure of the steepness of a curve, and whether the curve is increasing, rate of change will be positive, and if it's decreasing, rate of change will be negative. Now, an important thing to remember is that if a curve is concave up, it will have an increasing rate of change. Concave up, it will have an increasing rate of change. And I'm going to go ahead and go back to this graph right here. And here is concave up. And this is very easy to see if I draw what's called a secant line between those. Isn't that an average rate of change of 0? Okay, and then if I draw another secant line between these, do you see how my rate of change increased? Right, that's a positive number. That's really, really steep. Okay, and you may be asking yourself, hey, what about this this curve over here? Right, the function's decreasing. That can't be rate of change increasing. Well, if I go ahead and I draw again a secant line, isn't this a number? I'll just say like this is -4. But then my rate of change went to 0, and then my rate of change went to +4. So along this whole curve, right, my rate of change is increasing, -4 to 0 to 4. Okay, so rate of change is increasing. Rate of change increasing for concave up. Okay, now we're going to go ahead and we'll also talk about let's look at concave down. So if a curve is concave down, then the rate of change will be decreasing, a decreasing rate of change. And a good way to remember this is that D for decreasing means D down, okay? And so here's concave down, rate of change is decreasing. So again, look, my curve is increasing, right? Rate of change is positive. But then over this interval here, my rate of change is 0. And then my rate of change from here to here is negative. I'll say -4 here. So notice how my rate of change is decreasing. It was positive, and then it's 0, and then it's -4. And of course, I can do smaller and smaller intervals, right? That will help demonstrate this. So concave down, your rate of change is decreasing. Okay? Very important that you remember this simple fact. And sometimes, too, what they'll say is the curve is changing at a decreasing rate or an increasing rate for concave up. And sometimes, too, they'll link this portion, right? So my curve is increasing at a decreasing rate. So what they're saying is it's going up, but it's concave down. Okay, so let's go ahead and, well, I kind of just talked about this. Let's get into some examples in a second. The curve has a positive rate of change. The graph is increasing. If it's a negative rate of change, it's decreasing. Okay, so pretty simple to remember. All right, so let's look at some examples here. They say the graph of a polynomial function g is shown for -1 to 6. The function has a point of inflection at x equals 3. I like to add a point, a graph if they tell us this, and use the graph to answer the following questions. They say on the interval -1 to 2, so from here to here, the rate of change is it positive? Is it negative? Is it increasing? Or is it decreasing? Well, from -1 to 2, I'm increasing and then I'm decreasing. So my rate of change was positive and then my rate of change was negative. So it's not going to be positive or negative because there are points on that interval which break both of those trends. But I do notice that, hey, on this interval, it's concave down. We could even go to 3. So we're concave down. That means my rate of change is decreasing. Decreasing. Okay, so concave down. This told us that rate of change is decreasing. Okay, let's try another one. On the interval 3 to 6. So let's go ahead and let's look at 3 to 6. So 3 to 6. They say the rate of change is it positive? Is it negative? Is it increasing or is it decreasing? Well, my rate of change is negative here because I'm decreasing. And then I start to increase. So again, rate of change is not going to be positive or negative because it happens to be both of those things on that interval. But notice my graph is concave up. So that means rate of change is correct, increasing. Concave up means increasing, concave up. Okay? All right. Now let's go ahead and combine both of these ideas. So I'm going to get rid of these just so we can kind of see this. And they say on the interval 1 to 3, so from 1 to 3 right here, the rate of change is, so that's from here to here. The rate of change is positive and increasing, negative and increasing, positive and decreasing, negative and decreasing. So remember the first one, the positive and the negative, just tells you direction. So my graph is going down, that's going to be negative slope or negative rate of change. So it's not A or C. And then 2, remember we said on this interval that we're concave down. So the rate of change is decreasing. So we're looking for negative and decreasing. Answer D. Okay, here are some practice questions. Let's go ahead, let's do the first 2 and then I'll check in with you. So go ahead, try the first 2. Okay, hopefully you went ahead and tried these ones and you got the graph of Q is concave up. Well, that happens on A to C. So A to C here, we're concave up like a cup. And they say decreasing. So where are we decreasing on concave up? Well, that's A to B. Okay, number 2, concave down like a frown. C to E is concave down. And where are we increasing on that concave down interval? Well, C to D. So answer is C. Okay? All right, now we're going to kind of change this language in order to be about rate of change. Okay? So go ahead, please pause me, try these next 3, and then we'll talk through the answers. Okay, number 3, we have B. B to C. The rate of change is positive, meaning it's going up. and increasing, rate of change increasing, meaning concave up. Okay, so and that's kind of, you can annotate this. Rate of change positive means it's going up. Rate of change increasing, that means concave up, like a cup. Number 4, for which of the interval is the rate of change of Q negative and increasing? Pause me, try this. Okay, for this one, hopefully you got A on A to B. Rate of change is negative, meaning it's going down, and increasing, concave up. So that's going to be where we're concave up and we are going down. So that's A to B. Now note, please note, we've already answered this question, just worded differently in question 1. So in question 1, they say, where is the graph decreasing and concave up? That's the same thing as them saying rate of change is negative and increasing. Okay, pause me one last time. Go ahead, please answer question 5. All right, hopefully you got D to E. This is where our rate of change is negative. We're going down, and rate of change is decreasing. That's concave down. Okay? All right, hopefully you learned in this video what concavity is. Concave up is like a cup, concave down is like a frown, and how it relates to rate of change. If you're concave up, your rate of change is increasing. If you're concave down, your rate of change is decreasing. All right, give this video a thumbs up if you learned something. I'll catch you in the next one.